Water is the single most important substance on the planet, yet for 99% of human history, there were no maps to find it. If you were a nomad wandering the Kalahari or a hunter-gatherer in the Australian outback 3,000 years ago, you didn't have a blue dot on a screen telling you where the nearest spring was. You had to read the landscape. You had to become a detective of the earth. The survival of your entire tribe depended on your ability to interpret subtle cues that most modern people would walk right over. Nature writes its own maps, but they are written in a language of biology, geology, and physics. To find water, you didn't look for water itself, you looked for the signs that water was hiding nearby. The first rule of ancient hydrology is the concept of drainage. Gravity is the ultimate guide. You don't look for water on the top of a mountain, you look at the contours of the land. Water flows downhill. It collects in the lowest points of a basin, the valleys, and the dry washes. If you stand on a ridge and look at the landscape, you can see the veins of the earth. These are the drainage patterns. By following the path of least resistance, you eventually lead yourself to where the runoff accumulates. But what if you are in a desert where the rivers haven't flowed in a century? You look for the greenery. Vegetation is the most honest indicator of water. In the parched lands of the Middle East or the American Southwest, plants act like sponges that draw moisture from deep underground. Certain species are hyper-indicators. In the Sonoran Desert, the presence of cottonwood or willow trees is almost a guaranteed signal that the water table is shallow. These trees have deep tap roots, and they simply cannot survive unless their roots are touching the fringe of a subterranean aquifer. If you see a cluster of lush green growth in the middle of a brown, sun-baked plain, you don't just see a plant, you see a biological neon sign. It's telling you that water is beneath your feet. But you have to be careful. Sometimes trees are just hanging on to the last dregs of a seasonal rain. To be sure, you look for the behavior of animals. Animals are the ultimate masters of terrain navigation. They are biologically hardwired to locate water because they die without it within days. Birds are the best map makers in the sky. Pigeons and doves are famous for their drinking habits. They typically drink at dawn and dusk. If you see them flying in a straight line at a steady altitude during these times, they are likely heading toward water. If you see them circling or landing in an area of dense brush, you follow. Finches and other small birds are also reliable, but they stay close to the source. If they are chirping and hopping, you are close. The behavior of insects is even more precise. Honeybees are particularly useful. A honeybee usually flies no more than 5 to 7 miles from its hive, and it needs water to regulate the temperature of the hive. If you can track the flight path of a bee, you are on the trail of a reservoir. In many parts of Africa, the San people, one of the oldest cultures on Earth, have developed an incredible technique involving ants. They look for lines of ants trekking up tree trunks. These ants are often harvesting moisture from tree hollows or crevices where rainwater has been trapped for weeks. But let's talk about the hard stuff, the geology. Sometimes there are no trees, no birds, and no insects. You are left with rock. Ancient humans knew that geology dictates where water hides. You look for the contact point between two different types of rock. This is called a contact spring. When a permeable layer of rock, like limestone, sits on top of an impermeable layer, like shale or clay, water that filters through the top layer hits the wall of the clay and is forced sideways. It will eventually seep out along the cliff face where the two layers meet. Early humans learned to identify the color of the soil. White, bleached-looking rock might mean the area is perpetually dry. Darker, stained rocks often indicate long-term water seepage. Moss or lichen growing on a specific side of a rock formation can also signal that moisture is being released from a crack in the stone. This leads us to one of the most ingenious inventions in human history, the desert well. If you find a dry riverbed, you don't give up. You look for the point where the bend in the river is the tightest. Water likes to deposit sand and gravel in these bends. Even when the river is dry, there is often water flowing just beneath the surface in the deep sand. By digging down a few feet, you can reach the subsurface flow. This was the difference between life and death for thousands of years. The survival of the Aboriginal peoples in Australia provides the most extreme example of this. In the Great Victoria Desert, where temperatures can hit 120 degrees, they utilized soaks. They would track the movement of animals, identify the specific types of acacia trees that thrived in deep sand, and dig carefully into the basin. They would then fill the hole with rocks and debris to prevent evaporation. They created a permanent, hidden water source that stayed cool even in the heat of the day. This required a profound level of memory. You had to remember where every soak was. You had to remember which ones were reliable year-round and which ones were seasonal. This was the songline map. These were not drawings on parchment. They were stories, songs, and poems that encoded the landscape. By singing the song of a route, an ancient human could memorize the location of every water source for hundreds of miles. The music was the map. It was a cognitive archive of geology and biology passed down through generations. Now, consider the sheer scale of this intelligence. We are talking about the ability to store vast amounts of geospatial data in the human brain without a single line of written text. When we look at a map today, we see lines and labels. When an ancient human looked at the land, they saw a living system. They saw the slope of the earth as a slope of survival. They saw the movement of a bird as a coordinate in a three-dimensional space. The technology of water finding is actually a technology of observation. It is the practice of noticing what shouldn't be there. Why is that tree growing there? Why are those birds moving in that specific direction at that specific time? Why is the dirt slightly darker in this specific patch of the valley? It is a constant, hypervigilant interaction with the environment. We often think of ancient humans as victims of their environment, constantly being pushed around by the climate. The truth is that they were master navigators of it. They understood the physics of evaporation and the biology of plant transpiration better than most modern biologists do today. They understood that water is not a static resource, it is a cycle. By tracking that cycle, they moved across entire continents. They populated the most hostile deserts on the planet simply by knowing how to read the thirst of the land. Think about how much we have lost. We have outsourced our sense of place to satellites. We have replaced the intuition of the tracker with the algorithms of the GPS. We no longer look at the flight path of a bird to find our way. We look at a screen. We have become map readers, but we have stopped being landscape readers. If the power grid went out tomorrow and the GPS satellites blinked off, how many of us could walk to the nearest water source? How many of us would even know what to look for? We would be walking across a map that we cannot read. The history of water finding is a story of human capability. It is a testament to the fact that when our lives truly depended on it, we were capable of reading the language of the earth. We learned to listen to the whisper of the wind through certain types of grass, which often signals a change in the soil moisture. We learned to smell the ozone and dampness that precedes a storm, even if the clouds haven't appeared on the horizon yet. We spent thousands of years becoming fluent in the geography of the planet. Today, that language is becoming a dead tongue. The skills that kept our ancestors alive for millennia are now relegated to the fringes of survival training. But the signs are still there. The trees are still growing in the same places. The birds are still flying at the same times. The rocks are still sitting on top of the clay layers, waiting to release their hidden moisture. The maps are still being written. We have just stopped reading them. As you reflect on this, consider the disconnect between our modern lives and the physical reality of the world around us. We live in a world of instant information, yet we have lost the ability to observe the most fundamental aspects of our existence. We are surrounded by data, but we are starved for understanding. Is the loss of these skills just an inevitable side effect of technological progress, or have we traded our connection to the living world for the convenience of a digital one? Perhaps the most important map isn't the one that tells you where you are, but the one that tells you how to survive when everything else is stripped away. The earth is still speaking to those who know how to listen. The question is, have we forgotten how to hear it?